Hello, coders. So I noticed there was a lot of confusion and some kind of bad coding for the assignment regarding calculating a hard drive. And at first it seemed like a really simple assignment, but then when I looked at it a little bit deeper, it did appear to be a little bit complicated, especially for introductory course. So I decided to go ahead and make a video on how to do it, and I want to emphasize the way I'm going to do it is the way that I would do it. It's not the only way to do it. It may not even be the best way to do it. So, but I did it in a very clean manner, and I think easy to follow. So I went ahead and set my start page here, and I did this because some of you are leaving the automated comments at the bottom of the code right here. And I keep asking, please don't do that. Get rid of this stuff. So I'm going to go ahead and go over what you should do when you prep this stuff. And the very first thing you should do is just delete all of this commented stuff, this auto commented items. We don't want any of this. It's just not good. Okay, the next thing you should do is go ahead and enter the using and namespace. And we want to use std so that we don't have to keep using the std here. We're going to get rid of it down here where it comes defaulted. We can just get rid of this. We're not going to use that. Of course, what we want to also do is to, sorry guys. We also want to put our comments here for what this is and all of that. So I'll go ahead and do that. What you need to know are the formulas, and it doesn't matter to me if you Google those formulas. I don't expect you to know them. I didn't know them. So what you have to remember, what you should remember is that the actual bytes are different from the bytes that are advertised on the label of a hard drive. And that's because on the hard drive, the bytes are in base 10. And that's why you get, a 500 gigabyte hard drive or a 1 terabyte hard drive. Those aren't really the amount of bytes in the hard drive. And that's, again, because they're calculated in base 10. Of course, computers work in bits, and bits are 0 or 1, base 2. And 8 bits comprise a byte. And so when bytes are calculated in base 2, then you're going to get different numbers than when they're calculated in base 10, clearly. So there are 1,024 bytes, or bits in a byte. And so that's what we're looking for, is 1024 is the number instead of the 1000 that would be in the base 10. We're looking at 1024. So knowing that, you're going to have to use some formulas. Now I decided to go ahead for my stuff and use some constants, because this is a really good place to put some constants in. And since we're calculating the storage space, I decided to go ahead and use that. Here you'll notice that I went ahead and used the constant, and I'm going to use power, so I better go ahead and include up in here the CMath, which you got to use if you're going to use the power. Now, I used power just because it's cleaner. You could use 1024 times 1024 times 1024 times, basically 3 times, or and 1,000, times itself 3 times. But to me, that's just ugly. So I would rather use the powers. And since we have the math library, we're going to go ahead and raise those to the 3rd power. And that's what this means right here. This is 1024, and it's going to be raised to the 3rd power. This is 1,000 raised to the 3rd power. And the reason we're doing that is we're going to calculate in both the base 10 and base 2. So the 1,000 to the 3rd power is base 10, and the 1024 is base 2. Now, this is going to handle anything that's gigabytes, but these days we're getting hard drives that are terabytes. So we're going to want to use a formula for terabytes. So we're going to go ahead and grab that formula too. Okay, so here is for calculating terabytes. And so basically it's the same thing as I did in lines 13 and 14. The only difference is we're raising the same numbers to the power of 4 instead of 3. And that's because we have to raise it to the 4th power for terabytes. Okay, so having done that, the next thing we need to do is we need to declare some variables that we're going to use. These variables will not be constants, these are just going to be variables. I went ahead and put those in there, and now another thing I'm going to do here is I'm going to go ahead and create a while loop. And although this is not part of the assignment, it is very helpful to create a while loop so that you can have an infinite number of loops. And the reason is that way, as you're testing, you don't have to keep recompiling your code to re-enter entries all the time. So sometimes I'll create an infinite while loop and handle it that way. Okay, so we have our doubles here. These are going to be our variables that we're going to be using. I have user HD. This is going to be the amount that the user enters for their hard drive. So let's say like a 40 gig hard drive. This is the actual hard drive. This is going to be what's calculated. And then I'm going to use a few other variables called false bytes, true bytes, and then TB and FB also for true bytes and false bytes, because we're going to use those in our formulas going forward. So first of all, we have to get the user input. We'll get the user to enter a size, and we're going to assign that to the variable user HD. Next, we have process, and this is where we're going to do some processing of our data. So we have the data, now we're going to work with it. And the first thing I did is I created an if statement, and I'm going to check to see if the user hard drive is entered in anything greater than 1500 gigabytes. And the reason I'm checking for anything greater than 1500 gigabytes is because that's the point that we're going to have to shift to a different formula up here for the powers of 1024 to the 4th power instead of the 3rd power. And so what I'm doing is right here, we're going to assign these new variables, TB equal to TB underscore T, and that's because we're going to be using these constants right here. And the same goes for this next line on line 34. Okay? So that's in the event that the user enters a number greater than 1500. Now, if they do not enter a number greater than 1500, then we're going to create an else statement, and we're going to handle that situation. Okay, so here's our else statement, and this is going to be looking for gigabytes. So anything that's less than 1500 gigabytes is going to be calculated using the formula of power of 1024 to the 3rd power. So that's how we're going to handle those different entries. Now, it would be easier if on the input we just told the user, if you're going to use terabytes, then indicate terabytes, and then that way we could just we could handle it differently in our code. But I don't know. This is just the way I did it, and I think it's simpler that way. We're not asking too much from the user. Remember, if we can simplify what the user has to do, it's more likely that we'll get the correct input from the user. All right. So the next thing we need to do is we need to do our formulas as to how we're going to calculate this stuff. Okay. So now we have our formulas. And what we're looking for here is we're going to calculate the false bytes first. And so what we're doing is we're going to take the hard drive number entered by the user, so in gigabytes, and we're going to multiply that by the FB false bytes that we calculated up here. So basically, the user HD times this right up in here. So for false bytes, it's simply 1000 to the power of 3 is the formula we're going to be using. And so we're entering it right here, nice and neat. We're going to calculate that, and then we're going to use that output down below to calculate the actual hard drive, because the formula is going to be the false bytes divided by the true bytes. And then true bytes is going to be whichever one of these was selected, and that's going to be the power of 1024 to the 3rd or 1024 to the 4th, depending on whether we're talking gigabytes or terabytes. And once this little formula is done, then we're pretty much done. That's the formula. We've calculated it, and now the only thing we have left to do is to output our results. Okay, so here's our output of our results. We have the actual HD size, and it's a string, and then we're going to output the actual HD that was calculated here. A couple inlines, and remember, all this is happening in a giant while loop right here. And that's so that we can test different hard drive sizes. So let's go ahead and do that. I'm going to go ahead and run this now, and just all you need to do is hit your F5, and it'll compile. So build started, build succeeded, and the console comes up, and now we have our prompt to enter the hard drive size. We're going to start off with a 40 gig hard drive and see what happens. 37.25 is the actual hard drive size, and I do have a key to test against, and so I'll be checking that key as I enter these. Next we're going to do 60 gigabytes, and it comes up to 5588, that's correct. And we're going to go ahead and jump up to 250, that's like another common hard drive size. And that's the correct actual size, 232, and that comes up correct. Okay, let's go ahead and do a 500 gig, because that's, again, another common size. And that comes up to 465, that's right. Let's try a terabyte, and that terabyte here, since we're entering in gigabytes, we're going to enter that as 1000. And that comes up to 931, and that is correct. Now let's go ahead and do a 1.5, 1,500 gigabytes, which is actually terabytes. 1,500 gigabytes, which is 1.5 terabytes, and that's going up to 1.396, and that is right. Next, let's go ahead and just do a 4. That's another common one. So 4,000 for 4 terabytes, and that's going up to 3.637, and that is correct. And you could keep doing this, and so it's all going to come up right. And so the key I'm using, I'll go ahead and throw it on the screen so you guys can take a look. So this is the actual key. You go ahead and pause it here and test your own outputs. Should come up to these as you test your code. And I'll go ahead and kill the console. So I'm gonna go ahead and do a slow pass through the code again so you guys can see it. So again, I have my constants up here: 10 to the 24 to the third power, 10 to the 24 to the fourth power, depending on whether we're talking gigabytes or terabytes. But everything's entered in gigabytes. The doubles that we're using for our variables, and then like I said, this part isn't necessary, but I went ahead and threw everything in an infinite while loop just so I can test without having to recompile. Prompt the user for a size in gigabytes, assign the variable to the amount entered by the user, then process that data using a formula. This is the formula that I used, and this you'll find you can Google the formula and you're going to get some variation of this. And so it's up to you how you're gonna write it in your code. This is how I chose to write it. I thought it was pretty clean. Yes, you could compress this down farther, but by doing it in the way that I did it, it's easy to understand. Okay, and then of course output your data. So that's really it. Hope you enjoyed that. If you have any questions, let me know. Thanks.